डॉक्टर बाबासाहेब आंबेडकर ओपन यूनिवर्सिटी.
વિદ્યાર્થી મિત્રો, ડૉક્ટર બાબા સાહેબ આંબેડકર ઓપન યુનિવર્સિટીમાં ચાલતા BCA કોર્સમાં ડેટાબેઝ મેનેજમેન્ટ વિશે આજે આગળ માહિતી મેળવીશું. બ્લોક 1 યુનિટ 2 ડેટા મોડલ્સ. For the block 1 unit 1 we have covered the why database system, why DBMS is used, which are the benefits, which are the features, why we are dealing with the DBMS system. Now how the physically and logically model works, that is we will learn today. So for the data models, when we have covered this type of content, that is introduction to what is the data model and which are the types of data model available, and the brief introduction about the data models. So one of the most purpose of DBMS is to just provide the level of data abstraction by hiding the information of the data storage by level that we have already learned in unit 1, the physical level, the conceptual level and view level abstraction. Now we are going to just provide the model according to the level of data abstraction. So data model is integrated collection of concepts for the describe the relationship among the whatever the contents or data or constraint, the physical schema we have just defined. So data model is nothing but that is the collection of concept which we are going to describe with our data and whatever the relationship we are defining in our databases. So there are the three types of data model: object based, logical data model, record based data model and physical data model. So the DBMS take any number of or several approaches for managing the data. Each have its own whatever facts and whatever consideration individually defined by the approaches. So a data model is connection of description of data or figures or facts, that is the structure, what is the physical schema that is defined by the model. So a data model is a comprehensive scheme for describing the whatever data you are manipulating or managing in our database management system. So they are falling into these three category. So first, that is object based logical model. Object based logical model describe the data, that is the conceptual and view level. As we have know, these models are generally for the data abstraction level, how we are defining the structures or schemas. So this first level, that is object based logical model, that is work at which level? Conceptual level and logical level or view level. Then these models provide the flexible structuring capability to design our database management system or database which we are going to use. There are four types of different types of available model for the object based logical model: ER model, then object oriented model, semantic model and functional data model. Among these, for the recent criteria, this DBMS dealing with the ER model to display the whatever relationship established within the structure. For that, generally the ER diagram model get the more more famous for using the define the object based logical model. So entity relationship model, that is ER model. Second one, that is the record based logical model. The record based logical model are used to describing the logical and view level data in contrast to object level. Same object level logical model is also work with the or dealing with the conceptual level and view level data abstraction. Same as here, this is also used for the conceptual and view level, but the difference is that these models are used to define or specify overall logical structure of your database and provide the high level of description of the implementation. So as the level of whatever database structure that is available, that detail is available, but with this how we are implementing this schema, that details are also available with the record based logical model. So record based logical model are also named because the database is structured with the fixed format of the records. That means whatever data we are storing in our schemas, that fixed format, which are the domains for the majority values are coming from, these all are defined in this record level formats or models. So, each record types defines the fixed number or of fields. That means, if I am defining the structure for the student, so by this model we can also define the which are the fields are coming with this model or with this table, and among the fields which are values, these are available from different model, that is also defined at this level in this model. So, there are three most widely accepted record based data models, that is hierarchical, network and relational, and among these three, the relational model is more popular or more usable in a DBMS. Okay, so, there are three models, that is hierarchical, network and relational. We will also cover detailed model later on. The third is physical data model, that is these are the physical description of the data, how data is stored in computer, how the information are representing as a record structure, whatever ordering of the record and whatever path from where we can access this data, these all physically structures and schema are defined in this model. So, thus these are the models that describe the data as the lowest level. As we know, the data abstraction as a physical level that directly dealing with the schema, structure, memory management and performance. So, this is directly for the lowest level abstraction. So, it defines the detailed level of how records are stored, how we are manipulating, which are the accessible path. These all are defined in this physical data model. So, there are the not many much physical data model available, but there are two types of models available that are most common use, that is unified model and frame memory model for storing the data. Okay, so, these three are the majority types of data model which we can use, but generally from these three, generally DBMS working with record based logical model, and that have three, that is hierarchical, network and relational. So, now we are focused on this record based logical model and why we are using relational model, which are the pros and cons for accepting among these we are using relational. That reason we will just learn just first, that is relational model. This is the record based model. So, relational model store the data into the form of tables. As we know, relation is also anonymous name for the your table. So, the relational models always stores your data into the form of tables. This concept is given by the one of the researchers of IBM, that is Code, in 1960, and the relational model consists three major components. Whenever you are going to adopt the relational model, you must have to take care of these three components you have to define within your model. First, that is the set of relationship and set of domains which the database represented. So, that is your structure. Set of relations, that means set of tables, we store the different types of value, and among that values we can also define the domains. Domains is nothing but from where we are getting the value. Okay. So, that is first you have to define the data structure. Second, that is integrity rules that define the procedure to protect the data. That means, which are the for the data integrity, we must have to define some of the constraint. This data comes from this and that is the particular format. If any data upcoming with the different format, that we have to just make a restriction for storing that particular data. So, that type of rules we have to define for the relational model. And third, this most component, that is the operation that can be performed on your data. Which type of operation we can perform according to manipulation of data, the user of manipulation of DBMS data are different, and different users have a different types of access for the data. So, we must have to define this data manipulations with the operations defined by the users. Like common user can just access the summarized data, and another one, that is the DBA. The DBA like users are access the structured schema like information of your DBMS. So, you must have to define the operation that can be performed on data by user, that means how the data manipulation can be done. So, whenever we are going for the relational model, we must have to take care of these three components, that is relations, that means your data structure, relationships among the data by performing the data integrity, and how the data are manipulated by which user, that you must have to define with your model. So, that is our relational model. The properties of relational models, that means values are automatic, whatever value we can define, first we have to define the type, and according to type it will be done. Then the each row is unique, we have to define the unique rows. So, unique rows we can define by just providing the sum of the constraint. So, whenever you are defining the relation, first component we must have to define the relation. So, we have to define the values, that is automatic, that must be, each row must be uniquely. Why this require? Because if we have a same record with the two, so that becomes the redundancy or duplication. So, how we can get the actual information is this one, and that is accurate. So, to just remove that inconsistency, we must have to define what? Unique row, and that mechanism we have to develop with this model. And third, that is column values are same of kind, because whenever we are defining the data structure, we are also defining the type format for the data integrity, and from where we are just taking the data. So, whatever field that record stored by that particular field, that is the same of nature of your data. So, you must have to take care for the common values, and that is the properties of relation. Whenever you are defining the relation, that gives the guarantee whatever values you are entering in that particular field, that must be same kind of. Okay. One more properties of this sequence of column is insignificant. That means, once you have defined the columns, then you can use number first, then name first. That is not the necessary every time you have to use in that particular sequence. Okay. Then next, the sequence of rows are also insignificant. That means, whatever records you are just inserting in whatever sequence, that must be follow by the insertion, but that is not the compulsory. Whenever you are retrieving or manipulating the record, you must have to go for that particular sequence whenever you are inserting the record. So, that is not significant, you are able to use any row at any time. Okay. So, for that you know do not have to follow any type of order. Then each column has a unique name, because we can identify the individual column uniquely. So, that is the guarantee by the relationships, or whatever relations we are defining for the relation model, that is the properties of this relation model. Now, the basic just terminology or concepts we are using in our relational model, that is tuple. Basic terminology, that means some of the terms we are using for developing the relation model. The first one, that is tuple. Tuple is nothing but simple a row, the row in your table. So, each row of data, that is the tuple. For an example, let me consider the student table, and for the student we have student number and name. Whenever we are inserting the data as a 1 and 1 as a number and name as a ABC, then that particular entire record, that is considered as a one tuple. Okay. Next, that is cardinality of your relation. So, relation, as I have said already, relation, that is also known as table. So, that is the name, and the cardinality of relation, that is the number of tuples in a relation, that is known as the cardinality of the relation. So, as our example, that is student, that has a S number and S name, that is the two field, and if we are inserting 3 rows, that means 3 records, then 3, that is the cardinality of relation. Number of rows in your table, that is the cardinality of relation. Now, degree of relation. Degree of relation, that means the number of columns available in your relation or table, that is known as the cardinality of degree of relation. That means, if we have a student and we have student number and name, then the degree of your relation, that is 2, number of column in your relation, that is degree of relation. Domains, As I have already said, domain, that is this, that define the specific kind of data represented by the attribute. So, if we are defining the domain, that means, for an example, number and number and age, both are different fields of your table. For an example, for the student, we are defining the number, name and age. For the number, we are taking the same integer data type, and for the age, we are also taking the same number data type. But for the number, we are expecting what? The enrollment number or seat number, whatever sequence number. For the age, we are expecting what? The age of the student. So, the data types are same, but we are just insisting the data in a manner that is the age and that is the number. So, whatever domain, that is the area from where we are taking the value. Okay. So, obviously different kind data of the different types. So, we can use this domain for to specifying the area or what kind of value to be put in your table. Okay. Now, the body of relation. Body of relation consists just unordered set of 0 or more tuples. That facts are these: the first relation is unordered, record numbers do not apply to the relation. So, if our relation is unordered, then the number is not automatically applied. Second, relation with no tuples still qualifies as a relation. That means, if you are defining the table within your DBMS, and if that table had nothing, no any row, then also that is considered as a relation. Then third, relation is a set. The item sets are defined. That means, whatever item set, that is defined, but that must be unified. Unified, that means, if I have a student table and I am just adding the 4 records. So, 4 are the records for the individual one. So, how can I get the information about the which one is the record for number 1? If that 2 records are exist, that student number is 1, then how I can get the accurate information regarding the student 1? Because of duplication in your record or inconsistency. For that, so whenever you are defining the relation, then you must have to take care for the uniquely identifiable. For that, the constraints are available for to remove the duplications and for just making the unified or uniquely identification. Okay. And in this model, 2 sets of data are linked in a relationship. So, you can also define the relationships among the data by one to one, one to many and many to many. So, what is one to one, many to many or one to many? So, by taking this example, we will show how this relationship will be established among the data. So, first we are taking the table or relation, that is supplier records, second is part records and third is shipment. These 3 are the relation. In first relation, we have considered the student number, name and status, and for the part we are also using part, number, name, status, weight and city. Just for the status, for the shipment we have student number, name and quantity. So, just these are the sample database which we are using for defining the different name. Just see here, here student number, name and quantity. So, for the student number, that is this one, we are taking the reference of this table. For the name, we are using this name and this is the quantity. That means, this shows that this supplier just supplies this part with this quantity. So, for these we are using 3 all model, how we are defining this structure in our different model. So, we can define this model in these 3 ways. Okay. So, keys in relation, that means the table. We can define the relationship among the fields or columns which we are using in our relation. So, key is nothing, that is a set of column or column that define the occurrence of value that must be unique within that particular relation. So, for that we can establish two type of mechanism. First one is primary key, second one is foreign key. So, what is primary key? Primary key is an attribute which we can define in our relation, which gives the assurity that possesses the properties of uniqueness and also the redundancy. That means no duplication, no null value within our primary key field. So, that is the attribute, that is nothing but one field we can define the primary key. So, whenever we are defining the primary key, it will automatically gives the surety that record must be unique for the entire relation. And for the foreign key is also known as referential key. Whenever we require the reference of another relation column or another relation data we require in our current relation, then we can define the foreign key. For an example, we have a shipment table and we have a supplier table, then we have a part. So, shipment is what? That is who are the supplier and who are the which are the parts. That supplier supplies the part in which quantity. So, that shipment require the reference of supplier and reference of part. So, that nothing but the foreign key. Okay. So, these are the operational your relational model, and we can apply insert, update, delete all operation within that particular relation by just making the taking care of whatever constraint or whatever keys we are defining within the relation. So, we have to just take care of this data manipulation. Okay. Now, the advantages and disadvantages, that is the of the relational model, that is structure independence. So, if you are manipulating the data, that structure will never be affected. Second, that is conceptual simplicity. Whenever you are defining your data model with the different keys, then that become just simplicity of model. You can add supplier, you can remove the supplier without affecting other relations within your database. Ease of design, that means implementation, maintenance strategy, that is already defined with it and it is easy to use. And ad hoc query capacity, you can provide any type of query by just defining this structure and just putting your data. You can use any type of query of this language, the DBMS languages. The disadvantage of this is hardware overheads, it requires the hardware, and also the ease of design must be accurate, then you are getting the best performance of your DBMS, but if anything goes in your design, then you will get the bad results. Okay. So, this is the relational model. Then network model. So, this is the another approach or strategy to define the database. So, network model, that is defined in 1971. In network model, we are defining the diagrams, how the network nodes are available and how the data are manipulated. So, this network this is the popular model in 1971, but this is the data model where we can define the parts like bank that have a branch, that have a function, that have a account. So, that is the block diagram for, and each and every block that are just related with another, then we are using the connected to define the that particular relation. So, in this we are dealing with the one more data type, that is connector. Why connector we are using? For to just make a relation among the different block of our network model. So, the member record type, that means which are the data we are manipulating in our relation. So, or that particular node, and the connector is another data type, we are putting connection, that means that block is also related with another relation, another part. So, for that we are also using with the just another data type, that is connector. So, this is the example, same we are dealing with the supplier, part and shipment. So, you can see here the quantity, in shipment the quantity is different, just row different column. So, this is the quantity, These all are the supplier and shipment record. So, if I am adding one more, then I have to just change entire structure by adding one supplier, by adding one quantity, and I have to make connector which supplier supplies what. Just see here, this is the example. Just Sunit supplies which part? P1, that is nut, which quantity? 250. If Sunit is also supplies P2, then I have to add one more connector, that is the 300, and then P2. If that will be added. Again, this is the just structured view. In this we must have to take care of connectors. So, if I am adding something, then I have to add connectors with both the one. If more complex relation design is there, then we have to design more complex view of this model. So, generally this insert operation and the update and delete all are performed, but what happened if we are performing all these one, then the difficulty is there because of complexity. If I want to add the new supplier, then it is okay, but if I want to add one supplier with the shipment of quantity, then it will become difficult for to design. That is why we are using which one, that is the relation model. The insert, update and delete is very easiest. So, as we know the advantages and this ease of access, integrity, these all are maintained, but disadvantages is structure independence, because that is if we are adding something that must be change your structure. Okay. And last one, that is hierarchical data model, that is very much oldest model, and nowadays very new models concepts are available in hierarchy, that is tree level concepts are available. As you know, we have to define the tree diagram and one column have a one root. So, if I want to add something, then I must have to change entire structure of tree. So, this is the third one and oldest model we cannot use easily, and for these we have to just learn the concept of child and parent relationship. So, for these typical characteristics, model start with root, then root have a several branches, one child has one root and the branches leaves connected. These all are the strictly rules we have to follow. So, insert, update, delete are the operations. If we are adding something, then we must have to take care of this rule, then we can add. So, it is totally dependent of structure. So, it's earlier it will not use. So, the best one adoptable model is relational model. So, in this session we have covered the how data models are work in our database management system. So, here we are just complete the block 1, unit 1 and unit 2. In next session we will cover the unit 3 of block 1.